Hey everybody, my name is Stephen Feuerstein. I like to think about and talk about and write PL SQL, and hopefully you're here for the same reason. I am joined by my dog Moonbeam today, Falcor on the floor beside me, and we're going to talk about database triggers. And I was talking with Mark, who's here to help me with Q&A today, about the fact that we're about to start and I haven't figured out what I should be ranting about today. So lucky all of you. I'm going to skip ranting until maybe later in the show. There's, of course, so much to rant about, but we will simply retreat from the joys of the world into the joys of the cyber world, where we make all the rules. Everything is clean and not simple necessarily, but there's theoretically a solution for all of our problems. Let's have some fun with database triggers. So a database trigger. So we have tables. We have lots of different kind of objects and actions in the database. In an Oracle database, you can attach triggers to lots of different aspects of Oracle database. What we're going to focus on today mostly, almost exclusively, are table triggers, which is what you as a developer are likely to run into. And so you can actually say when something happens on the table before a row is inserted, or after a row is inserted, or after the statement is executed, take these actions. There are other kind of triggers. There are logon triggers. You can say, after I log in, take a certain action. You could say, after I log in, raise an error and stop anybody from logging into your database. You could say, I want to set up some VPD context information every time anybody logs in. And then there are Ddl triggers. You could say things like, I don't want to ever let anybody delete a table. So you could set up a Ddl trigger on deleting tables and raise an error. So lots of different interesting kinds of triggers. Oh, there are also, instead of triggers, you can apply to views. So you can do DML, inserts, updates, and deletes on the view when you're actually doing operations underneath the covers to individual tables. Lots of different kinds of triggers. We're going to focus mostly on table triggers because they're the most commonly used by developers, and there are all sorts of issues to talk about. Good morning, everybody who's been saying good morning on the chat. Glad you could join me. Let's take a look at some code. Thank you, Mark. So we'll start out with some simple examples, and then we'll explore some of the nuances of triggers. So first of all, here's a very common sort of trigger. This is a row level trigger on this table. There can be row level and statement level triggers on a table. And this says, before I insert or before I update, execute this code. So the rule I have in my table is I've got a username column, and it has to always be uppercase, stored in uppercase. So there are a number of ways to do this, but let's focus on that point for just a moment. Every time a row is inserted or updated in this table, I want to make sure that username is always uppercase. That's the core value of these kinds of triggers. There's no way to get around it. This will fire every time or just before you do an insert or an update, or try to do an insert or an update. So this is kind of a gatekeeper into the table, ensuring that this logic always runs. Now, as we're going to get into more of the conversation around triggers, there are a lot of reasons to not use triggers, avoid using triggers. You could accomplish the same thing, which is to say, every time I insert or update, I must make sure that username is uppercased. You can do it without a trigger, guaranteed 100%, but only by building a PL SQL API on top of the table. So you have an insert procedure that does the insert, an update procedure or a variety of update procedures that do updates, and then you don't grant any access to the table. You only grant execute authority on the package. That's a small part of what's called Smart DB, an architecture for building highly secure, highly maintainable, highly performant applications. But I'm not going to get into a lot more details on Smart DB. If you're not in a situation where you can create these table APIs and guarantee that everybody always goes through the API, then the database trigger's a good alternative. So here we go. I'm going to uppercase the name. I'm going to trim it, get rid of any leading trailing blanks, stuff it into the column. Now, here's another typical example, which is using audit columns. So many tables have created by, updated by columns. So before I insert or update, I want to make sure that I've set my different audit columns. This is a very simple example, and it's kind of it's the way I used to write these triggers. There are a couple of issues with them. One is that you might say, well, why am I setting updated when I'm doing an insert? That's a really good point. I think, in fact, that you should not set updated until the row is actually updated. They should be null. So more commonly, I would write a trigger an auditing trigger more like this. So if I'm inserting, this is one of 3 event functions in the DBMS standard package, like the standard package. You don't have to write DBMS standard dot. You can just say if inserting. So if the trigger is doing an insert, then set the created and created by. If I'm doing an update, then set the updated and updated by. So that's something to keep in mind. A couple of other things that we can talk about right away is you have these pseudo records, :new and :old, which is really nice. Inside the trigger, you have a record :new that looks just like it was declared with person, in this case, %row type. So all the columns are available as fields in the record. And when you change them, this pseudo record is then going to be used to do the actual insert or the update. Really, really nice. The sad thing about new and old is that they're not really records based on %row type, because what I'd really love to do is something like this. Let's see, I've got my audit package. Audit package. What are you doing? Package dot log data, whatever. And I'd like to be able to pass new like that and have it be based on a %row type parameter. That is not allowed. They're not compatible. Maybe someday the PL SQL team will get around to doing that. But at this point, you have to actually break out the individual attributes as columns, pass them as separate parameters. Very annoying. In any case, these are some very simple examples of row-level triggers. And of course, I could say after, and this would run after the insert or the update occurred. And if I didn't have for each row, then this would be a statement-level trigger. So in other words, I'd say, update table set salary equal to salary times 10%. We're giving everybody a 10% raise. It's one update that will be applied 107 to 107 rows. So row-level triggers will be fired for each row modified. And then when it's all done, or before it even starts, the statement-level triggers will fire for the overall processing. And we'll talk, at least in the context of mutating triggers, as to why you might want to have those 2 different things. Okay, so there are a couple of ideas. Let me pull up my notes, because I wrote a blog post, of course, to go with my presentation, and you're going to see that after we're all done today, but I've got my list of things to talk about. So there are some basic introductions. Now, one interesting thing that came up for years inside Oracle database is I could create multiple triggers. I could say BRIU2, and I could do something else here. I could have multiple triggers on the same event before insert, before update. And there was no guarantee about the order in which they would be executed. That's really unfortunate. So Oracle came up with 2 ways to get around this problem. The first, introduced, can't remember when now, is the follow syntax. Oh, Oracle 11G. Oracle 11G added the follow syntax. So if you do have multiple triggers on the same event, you can actually say this one follows that one. There's no precedes, just follows. So you can set up a sequence of database triggers. But the better approach, starting with 11G, is using what is called a compound trigger. So here's an example of a compound trigger. So here's a trigger on emp-test, compound trigger. And what this essentially does is combine sort of packages with triggers. So inside my trigger, I can have a section, let's put some blank lines here, after each row, after statement, before each row, before statement. So I can have these separate blocks within the same trigger. And so there are 2 big advantages to compound triggers. One is you don't have a bunch of different triggers all over the place for this table. You'd have one trigger and all the logic for potentially 6 or 7 or a dozen different triggers in one place. So from the standpoint of managing your logic and triggers, which can often be tricky, it's a great solution for that. The other really nice thing about compound triggers is that it has a scope, it has a state, like a package has state. So I can actually declare variables at the compound trigger level that can be accessed throughout all the different sections of my trigger. The reason this is so nice is that you can use compound triggers as a solution to mutating table errors. I'm not going to spend a lot of time on this. I suppose you run into it occasionally, and then you'll go and search your solutions and come up with a solution, and certainly you can do Live SQL for that. But here's the idea. Let's look at my compound mutating. So let's see. Yeah. So first of all, what is a mutating table trigger or a mutating table error? in general, for row-level triggers, you're not allowed to write code that touches the table that you fired from. So I'm firing this for employees, and then I'm trying to update employees, and the table is in an uncertain state, an unstable state. It's mutating. The table itself is mutating. So there's no view of that table that's consistent to be used inside the trigger. So if I try to touch the table at the row level, Oracle says, sorry, mutating table error, can't do this. But you don't have that restriction at the statement level. So the general solution to a mutating table error is at the row level, you don't do anything. You don't do the updates here. You store the information you need to perform the operation at the statement level. Historically, that has meant building a package. The package has a collection in it. So that's the package state. And during the execution of my triggers, I have that same single package state. And I basically load up this array with the data that I need. And then at the statement level, iterate through the collection to do my processing. So I won't go through all the details here, but here's all the code to build all that stuff. And then on my statement level, before I initialize, so I clear out my array. For each row, I simply add the employee information. And after, I then make equitable or apply the logic to everything that's been added to those arrays. So that's before compound triggers. All these different triggers, this big package, needing to clean things up in advance, et cetera, et cetera. With a compound trigger, things get a lot simpler. Well, simpler somewhat, maybe not a lot. It's not like you're getting rid of a lot of the code. So you can see now that in my compound trigger, I've moved those declarations into my state, my trigger state, not my package state. And then I have each of my sections. I'm still loading the information up at the row level. And then after statement, I simply do the processing by going through the entire contents of the array. I no longer have to do this initialization, which is really critical. You might have stuff left in your array from the past operation. So it's a lot cleaner and simpler. Definitely, if you look at or you run into mutating table errors and triggers, use the compound trigger as the core implementation for fixing it. You could still have a package. This code could still be called from inside a package. That's okay. You generally want to keep your trigger logic as compact as possible, mostly by pushing it all off into a package, procedure, or function, and calling those. Okay, just kind of cruising through all my different things to tell you about here. Let's see. Yes. So here's something else to look at. Did you know that you can commit inside a trigger? Now, usually you can't commit inside a trigger if you try to. In fact, let's hold off on that for a second. What I want to do is talk about context switching and triggers. So hopefully you're all aware of for all and bulk processing in PL SQL. And the idea here is that instead of doing row by row inserts or updates or deletes, for example, here's a row by row insert. Instead of doing a row by row insert, you can switch to for all. And then you pass the insert once to the SQL engine. It does all the processing for all the bind variables in your array, passes the result back, often much, much faster. So one thing to think about here, though, so generally you should use this, no question about it. But one thing you should think about is whether or not you have triggers on these rows. Because if you have triggers, it's going to have a big impact on performance. For example, I think I've got some numbers down here. So just to run through this, here's my insert row by row. Here's my insert for all. And this script, which I've also loaded on Live SQL, basically does it for 10,000 rows, 100,000 rows. Then I create a trigger. And I do the same test again. And then I create a procedure that's called from the trigger. So what I'm looking at here is the cost of a context switch from SQL to PL SQL. The point of for all is to avoid context switches. But if I introduce the trigger, have I introduced a context switch? If I call a procedure from inside my trigger, have I introduced another context switch? Scary stuff. So when I ran these tests, here's what I found. And the numbers will vary on execution, but they've been pretty consistent. First of all, you can see a big difference between using a for loop and for all. From 2200th of a second, or for 100,000 rows, 128 to 55, 129 to 6. Then I add a trigger. And check it out, 10 times slower for the for all. It's still a lot faster than the for loop, no question. an order of magnitude faster than the for loop, but it's gotten significantly slower. Interestingly, if I call the procedure, I've seen these numbers bounce around a bit, but I think you can pretty much see that there's not much of an impact of adding the procedure call from the trigger. In some other runs, it actually was faster. So it's right around the same area of performance, probably varied by what else is going on my laptop when I ran the test. So the point here is that if you have a trigger on a table that you're executing bulk operations against, for all operations against, what you might want to do is consider disabling the trigger before running, enabling after. And I have a script. Let's actually go over to LiveSQL. LiveSQL. That was the script I wanted to show you, but I'm going elsewhere. So lots of different scripts on triggers here. Let's find my enable disable. This is a procedure I wrote that you can run to just set the trigger status. So for a given table, what action, whether you want to filter on name. So I can just say, disable all the triggers on this table. And it goes through all the triggers it can find. From user triggers, you can change this to all triggers as you need to. Does an execution of a dynamic DDL statement, which, as you may remember from a few weeks ago, will automatically do a commit before and after the execution of the altered trigger. So keep that in mind. There's a commit going on here. But it'll actually disable all the triggers. Then you do your for all operation. Then you enable the triggers. Obviously, you need to be really careful and look at your trigger logic and decide if that's okay. For example, with your audit columns, you might wonder, well, is it okay? What do I set these to? If I disable the trigger, first of all, if these are not null columns, you've got a problem. But if I disable the trigger, what do I set them to afterwards? You might say, well, I'm just going to set them all to the same, created and updated. Whatever you decide. The point is, you have to figure out what makes sense for you. Wow, I've been talking for a long time. Do we have any questions? Is it that quiet a group? Yes, it's a quiet group for questions. Lots of greetings. That's good. Looks like I've got one. I learned the hard way to disable all triggers before a massive update. Yes, we often do learn the hard way, but it can make an enormous difference. Okay, so now let's go back here into my little for all test, and I want to make one change. What I want to do is change my trigger. Wait, trigger. There, trigger. To do a commit. Let's recreate this trigger. Oh, yeah. Now I guess it's going to reset, do all the wonderful things it does. Oh. Set there. Reconnect. And by the way, as I mentioned in Twitter, in case you follow me on Twitter, if you have any interesting stories of your experience with triggers, love to hear about it in the chat. So feel free to tell us more, as Rachel did. Here's a comment from Nils. But disabling the triggers also disables them for other sessions, so you got to be really careful before doing it. Absolutely, Nils, no question about it. So the issue here is you're looking at some massive update. Chances are it's being done as a batch process, maybe off hours if such a thing actually exists anymore. So no question, be very careful. And you may not want to even do it unless you realize there's a problem. But if you're running your batch process and it's taking quite a long time, you might take a look and see what's going on trigger-wise. Okay, let's see if I've got my session back. It's back. So let's compile this trigger with a commit inside it. Notice it says, no problem. You can have commits and triggers. And now I'm not going to do the 100,000. We'll just do 100. Run this. Cannot commit in a trigger. Oh, that's so sad. Well, you know what? That's not sad at all. That's really good. You do not want to be doing commits and triggers. The trigger is part of your transaction. It's a trigger on a table that's part of a transaction. You'd never really want to commit, but you can commit if you really want to. You can add a pragma autonomous transaction on the trigger, and then you can make changes and commit those changes and really screw things up. So let's talk about DML and triggers. In general, you should not ever have DML, inserts, updates, deletes, and triggers, or in procedures and functions called by them. Now, the exception I might say to that is something like an audit, a log, a trace. I want to trace what's going on in my application. There's some funky stuff going on in my trigger, so I'm going to write out a row saying I got here, I got here, I got here. So that's a logging procedure. That should be an autonomous transaction, so you write it out to your log table and save it. But you shouldn't have business-specific DML inside your database triggers. What misery that will cause. So first of all, a general point. If you find yourself saying, I guess I should add a pragma autonomous transaction to my trigger because otherwise I can't get it to work, stop, stop, stop. Rethink the whole architecture. You're off in the wrong direction. You should simply not do that. In general, you don't want to have DML inside your, or non-transactional statements inside your trigger, because for some types of triggers like updates, it might actually run more than once. So Tom Kite has written about this extensively on the Ask Tom blog and in Q&As. You can read about trigger restarts. But if something is going wrong in the process, and this is deep inside the database, Oracle might stop and try again. And if you have a before trigger, for example, that sends out an email and Oracle has to retry 10 times, it'll send out 10 emails. If you have a DML operation that's executing in the before of the table before trigger, it's going to execute multiple times. So in general, you want to keep that sort of thing out of database triggers. They should be very lean and mean, performing some minor adjustments on the table, like setting audit columns or uppercasing usernames, but try not to let them get a whole lot more elaborate than that. There have been some good comments here from about disabling triggers, right? You can use and set a package Boolean. Oh, what a nice idea, Edith. So basically, you can set a Boolean flag through a package API, so it's only disabled in your session. And as Mills points out, they'll still be executed. That'll slow down batch processing. For sure, there'll still be the context switch, but it would be less of an issue because you're not executing the logic. Right. So triggers are PL SQL. So there is going to be a switch. And Rachel also mentions, sorry, Mark, I see triggers with extensive data validation inside them. So triggers might have a lot of logic like that inside them. Data validation might make a lot of sense, right? I want to do a whole bunch of different checks against the data coming into the table. The first and most important thing is write a package, put all your validation rules in your package with procedures or functions as makes sense. Call those programs in the trigger. At a minimum, that's what you should do. Ideally, they would be called outside before you get to the insert in the table through your package API for doing your inserts and updates, or even in an Apex app or wherever you're doing your front-end work in validations at the front end. The most important thing is not to repeat the business logic from one place to another. So define it once in the package. If you got to call it in the trigger, call it, but also make sure it's called elsewhere. And maybe it'll never get to the point of needing it in the trigger. All right, let's see what else I got to talk about, because my gosh, I'm going on and on. I think that covers most of it. Avoid non-query DML, no autonomous transaction pragmas. Right, now there's also something called the when clause of a trigger. Let's see. Do I have a script of that? Gen when clause. No, that's the wrong when clause. I have a gen when. Okay. Let's see. Is that a trigger? Here we go. So when I create a trigger, all that uppercase, it's hard. It's hard on my eyes now. But the formatting is better. Whoops. Sorry. I can't even find my file. There it is. Okay, sorry. So what I can say on my row level trigger is I can look at the values of old and new. And oddly enough, you don't put a colon in front of it. It's just old and new. And in some cases, I might be able to shortcut the execution of the trigger. So for example, I only want to run this if a specific column is not null, because if it's null, there's nothing to do. So you can add a when clause, and this is actually a generated when clause across all columns that will shortcut execution of the trigger, but it will have been executed, just like we saw before with Judith's suggestion about a Boolean variable and Nils pointing out that it will still run. You'll still get the switch, but you can shortcut what is actually executed within the trigger with the when clause. Let's see. Finally, I'll talk about instead of triggers, and then we'll see if we have any questions and comments. So let's say that I've decided to move away from tables, and in terms of developing against database objects, and I have a set of layers, of views of layers above the tables. But I still want to execute DML operations against those views to underlying tables. Now, some views can have DML operations on them. If it's a select from a single table, then you could perform DML through the view on the table. But in something like this, where I have a join across multiple tables, what does it make sense to say insert into delivery info? So that's where instead of triggers come in. So with instead of triggers, I can say when an insert occurs on this view, execute this code instead. So you can basically remap all the DML operations on that view to the appropriate action on one or more underlying tables. Very handy. Okay, let's see. I think that pretty well covers it. So let's go back and just talk to you directly about triggers a little bit, then move on as well. Or sysop map non-null in the conditions. Cool. Thanks, Knowles. I never even heard of that, and I'm sure I'm going to forget about it really quick. Right. So the when clause, the point. So the when clause is not a part of the PL/SQL operation of starting the trigger. So it is better than having the Boolean expression inside the trigger. Okay. So those are a lot of comments about different aspects of database triggers. You can see there's a lot of nuance here. More importantly, probably the biggest question about triggers is when you should use them. So we'll publish a blog post right after this session. And there's a link to Tom Kite's blog post, which is The Trouble with Triggers. There's also a link in the blog post to Tim Hall's Oracle-based set of articles on triggers, including thoughts on when to use them and not use them. So there are very good reasons to avoid triggers. I would say if you're finding yourself building a lot of triggers with a lot of complex logic in it, you're probably taking the wrong approach, and you need to at least move to a package-based API that implements all that stuff and ideally attaches it to the insert procedure as opposed to the table itself. But again, you have to have some good controls in place so that people can bypass the insert procedure and just do a straight insert and avoid what you took out of the triggers. But use them with care. Be very, very wary about DML operations and commits and rollbacks and so forth inside of your triggers. And then while it might have somewhat of a drag on performance in some cases, you're probably not going to notice many of the downsides of using database triggers. Okay, so that's the end of my talk for today. And feel free to add questions and comments as I do my little finishing points. And that's a good point by Claudio, right? Instead of triggers really are nice. You're essentially building an API around your underlying views, and you get a full abstraction from the tables. So there are two things. One is that this week, we're going to make a donation to, we're going to take a break from Ukraine support, and we're going to get back to helping heal our planet. So there's an organization called Oil Change International. Love the name. And the website is priceofoil.org. And it's an organization that helps expose the cost of fossil fuels and helps facilitate the ongoing transition to clean energy. Looks like a great organization. It's certainly a great cause. It was so dismaying to me when Putin's war on Ukraine started. And there wasn't even the thought, as far as I could tell, of national leadership like President Biden, the Republicans, saying, we're going to take action to support Ukraine. This is going to have a big impact on the international energy scene. Please, everyone, do all you can to reduce your energy consumption, which is what we should be saying every single day. But not even in this context could it be said we are so hooked on, and in fact, now increasing production of oil and gas. It's a disaster for our planet. I won't repeat all of that. That's where our money's going this week. And in terms of my favorite book, I think I've probably mentioned this one before, but it's certainly a favorite topic, and that is sentience and which creatures are sentient. So if you happen to be one of those humans who isn't really entirely convinced yet that non-humans are sentient, can think, can feel, can judge, can do all sorts of things, this is one of those books that will change your thinking. Now, there are others I talked about. In fact, I think maybe my first Feuertip was I focused on Out on a Limb, which is a book about living among black bears and helping rehabilitate black bear orphans and getting insights into black bear society and the sentience of black bears. And I think for most of us, accepting that mammals are sentient generally is pretty much done, not that difficult. But fishes, So this book on fishes was really, really fascinating to me in a number of ways. First of all, one of the first things this guy talks about is they're not fish, they're fishes. We actually verbally use the word fish very differently from other creatures. For example, the word fish is not only for the species or the genus, whatever, but also for the term we use to hunt them. We don't say, let's go deer today. We say, let's go fish. And I think a part of that is because we really want to suppress the idea that these are living, thinking creatures, because we kill them in such massive numbers. We kill hundreds of millions of fishes and mammals, mammalian water animals, every day. Every day. It's crazy. Okay, so, but what a fish knows is really remarkable. I won't go through all the details. You can read about it and hopefully read the book. But one of the things that really caught my eye about in this book was that he described cleaner fishes and how they actually have established economic systems. So a cleaner fish will attach itself to another larger fish, sometimes clean inside their mouth or clean their gills or clean their scales. And it's a symbiotic relationship. Well, these researchers discovered by going and watching, what a job, that the cleaner fishes would actually treat local fish, their neighbors, differently from fish who came from further away who they didn't know. They would essentially charge them more in terms of how much time was required, or I don't even remember the details of the barter system that was involved, but it was really clear that these fish could identify their common friends that they hang out with and clean, and the others who are not part of their group. Fish can identify each other visually as individuals. We used to look at fishes and say, well, you know, they just all look the same. How could they notice any difference? Well, they see in the UV spectrum, and there are different patterns of lights, of colors on fishes. All right, probably that's enough of that. So, but I do encourage you to check it out. And in general, if you are still not really clear on the fact that just about every species we look at in any great detail is clearly sentient, catch up. And I'll actually post on Twitter a thread soon that goes through a number of different books to give you information about a variety of species. Fishes bartering, yes. Rachel, you got to check out the book. It's just incredible. But really, to be honest, anytime humans slow down and take the time to watch non-humans carefully, it's always amazing. Organic life in every aspect is totally amazing. Before asking, do fish think? What about asking, do humans think? Yeah, they think, they feel. They're just like the rest of the species out there, except they can control fire, have opposable thumbs, and store knowledge externally from their brains, which I think is the original sin of humans that have created all the problems to come. And on that note, hope you enjoyed my talk. Sorry if I kept you on a bit long. Take care, stay safe. I just traveled to Florida to see my mom. I wore an N95 mask all the way there and back. Do not assume that you will not get COVID. Do not assume that COVID will not hurt you badly because you're vaccinated. Long COVID is a deep, dark mystery, and it's very scary. Avoid the plague as much as you can, like a plague. All right, take care, everybody. See you in a couple of weeks. Happy coding.